So we've talked about this thing called a derivative, which was a slope of the tangent line. We've gone through a couple different ways to compute this derivative. We have like the standard definition, we have the alternate definition, and we've practiced doing numerical stuff. But what I like, and the AP exam tends to like a lot, is they like talking about graphs. And today is all about the graph of the derivative. And so we're going to start talking about the graph of derivative. And I'm going to need some help. I'm going to make it where I can, and you don't have to say anything. All right? Okay, so no, you don't have to say anything. What I would like you to do is, there's going to be a time where you have to sort of input numbers. And what I want everybody to do is sort of type in the number you think represents. All right? And nobody's, you're not, I'm just trying to get some sort of feedback. All right? All right, so, when I make up a graph, I like making up an XY chart. I mean, pretty much anytime I'm trying to come up with a graph that I've never seen before, I do an XY chart because I can pick different values for X, I figure out my values for Y, and then I plot all of those points, and that gives me an idea of the graph. All right? So that's what we're going to do. If I want to know what's the graph of the derivative, I'm going to make an XY chart. Here's my X's, here's my Y's. I may need to, so we can kind of scroll and do this later. I'm going to make my XY chart over here. I'm going to make a copy of it over here because we're going to have to scroll up, and I still need this information. So, what do we do? Well, so f prime, anytime you see f prime, this is talking about slope. So we're interested in the slope of a line. So if I'm at -5, 1, 2, 3, 4, 5, I'm here. What I want is an estimate of the slope of the tangent line. Well, how do you do that? Well, here's my little line. I'm going to try to make a tangent line. So I'm going to make a tangent line here. And what I'd like everybody to do, if this is your line, I want everybody to start typing in a decent estimate. It doesn't have to be perfect, but I'd like an estimate for the slope of this line. Start typing. Okay. Wow. Everybody thinks 2. Well, do I think 2? I don't know. If I do this, yeah. Okay, we got 5, 3. All right, we're getting, positive things I'm seeing. Everybody's at least giving me a positive slope. Awesome, right? You're also giving me a slope greater than 1. Even better. And so when I look at this, and I think kind of the minimum number I'm seeing is 2, and then I'm also seeing 3. I mean, I'm going to put 3 because I've done this problem a few times, and I think it looks nicer if we have 3. So at -5, it's got a slope of 3. Okay. All right. Now let's see what happens at -4. Here's my slope. Okay. So here's my slope at -4, and now let's see the numbers come up. What would we call this one? Anybody got any ideas? Well, can we agree that this slope is smaller than this slope? Right? Does it make sense that this is a steeper part of the graph than here, right? Okay. So this has got to be less, right? So I think we can get by with a 2. I think everybody's I'm getting numbers that are pretty close to 2. Now I've got 3 over 2. I got 2. I think 2 works, so I'm going to put 2. All right. Let's see what happens at Let's see what happens at -3. What do we get out of this one? Definitely less. Any guesses? Yeah. 1, and to be honest, it might be a little less than 1, but we'll put 1. And I'm going to fudge a little bit because when they printed it didn't match exactly up. What about at -2? Okay. Yeah, it looks like we've got a 0, right? I think we can pretty much do a good consensus that we got a 0 on that one. All right, now let's see what happens at -1. Any guesses as to what this is? I like this. I got -1.5, I got -1, I got -2, -1.5. We're all in that range somewhere. Like I'd like to say -1, but it may end up being -1.5, right? I don't know if it'd be a -2. The -2 is that slope. And I don't think a -2. I think a -2 is going to be a little too steep. But definitely between -1 and maybe 1.5. I'm going to see how the graph looks if I do -1. Okay. All right, now let's talk about 0. Oh, well, that's why. That's probably why we wanted to say that's a little bigger than that. Because I think we can agree that this slope and this slope are going to be different. Let's see. Here's our slope. Yeah, I may need to say this is -1.5, and then this is probably a -1. All right, now we're going to cheat a little bit, and then our slope at 1 is going to give me a 0, and then our slope at 2, well, that really looks like a 1/2 to me. Does that look like a 1/2 to me? Like 1/2. Yeah, I think I can get by with a 1/2. And then at 3, it was supposed to line up, it didn't, so we'll call that a 0. Yeah. And then at 4, looks like we've got a negative number. Almost says -1. -1, yeah. So that's -1. And the -5 is actually even steeper. All right. So we've made an XY chart, right? We've gone through, and it's painful. We did this. Don't worry, when you have to come up with the graph of the derivative, we're going to come up with some tricks. But this is kind of painful, right? I've gone through, and it's like at every point I sort of agonized. What's the slope, right? What's my slope at each point? I made a little chart, and now let's see what we have. I want to know what this graph looks like, so I'm going to plot my points. So I guess since I use blue, I'm going to graph the derivative. And so when I graph the derivative at -5, I'm up at 3. So 1, 2, 3, I get a dot. At -4, I'm at 2. At -3, I'm at 1. And at -2, I'm at 0. At 1, I'm at -1.5. Yeah. At 0, I'm back at -1. At 1, I'm at 0. At 2, I'm at 0.5. Then I'm back at 0. Then I'm down to -1. And pretty much at this point, I just need to connect the dots. The right side's fine. Maybe I should have been a little better with these dots. I'm going to put them up a little higher just so I can kind of get the picture I'm looking for. But if I were to graph this, what I end up with is this little curve. So what do we know about our graph of the derivative? Right? So here's our lovely graph of the derivative. There are a couple of things you want to look for. in finding what the graph of the derivative is. Flat spots on the function translate to zeros on the x-axis, right? See how that's a flat spot, there's a 0, there's a flat spot, there's a 0, there's a flat spot, there's a 0. All right, and this is, we're going to go over this a bit. If the function's increasing, this graph is increasing, then my derivative is on the top half of the graph. See how my function's decreasing? Anytime your function's decreasing, your derivative's below the graph. We're increasing, it's above; decreasing, it's below. All right? And those are the two big ones. The two huge ones as far as figuring out what the graph of the derivative looks like is you say, well, if this thing is increasing, then my derivative's got to be positive. And you think about it, if your slope of your tangent line is positive, that means your derivative is positive, and if the graph of the derivative is positive, then if your derivative is positive, that means it's above the x-axis. If your derivative is negative, it's below the x-axis. All right. So, when you're about the y values of the graph, when the function reaches the relative max, min, levels off, and what do you notice about the y values of the graph? The derivative is increasing. Well, then the function's above. Then the derivative is above. I can't answer those questions. All right. And so now, we're going to go through, actually let me pause just for a second. So, seeing that this is probably the first time you've had to do these, I'm going to talk about how I look at this. If I'm given a function and I have to find the graph of the derivative, the first thing I look for are flat spots. So for this particular problem, I see it has 3 flat spots. It's got a flat spot here, here, and here. So if I've got a flat spot here, here, and here, I know, and I'm going to call this, I'll call that -1, and I'll call this 1. I know that my graph of the derivative is going to cross the x-axis here, actually, not quite at 1, but a little bit less than that, here, and here. So I know it's got to cross at those 3 spots. That's the first thing I look for. The next thing I look for is I see that from here to here, the function is increasing, meaning my derivative is on the top half. So I know that it's going to do this. I see that my function is decreasing from here to here, so I know it's got to be below the x-axis. Now where it gets a little tricky, and you'll get used to it after a while, is just because it's below doesn't mean it just goes all the way down. It just means it's below. And so it's got to go below, but then you got to hit this dot, so we're going to go back up. Then I notice from here to here the function's increasing, and since it's increasing, I know I'm above the x-axis, and then from here down, I know it's decreasing. Since it's decreasing, it's got to be below the x-axis. And so now I need to look for which one of these pictures matches this. And it looks like D does. Because we need something that's above the x-axis right before 1. And actually, as I look at this, this is not above the x-axis, this is not above the x-axis, this is not above the x-axis. Even if I were to scroll down here, that's not above the x-axis. All right? So, next up. Why isn't it C? So, the graph of the derivative, because it's increasing from here to here, the derivative has to be above the x-axis. Anytime a function is increasing, the derivative has to be above the x-axis. And if you look, this 0 corresponds to this flat spot, this 0 corresponds to this flat spot, this 0 corresponds to this flat spot. And see how this is increasing? Here, color code it. This is increasing corresponds to this being above the x-axis. This decreasing part corresponds to being below the x-axis. And then I get this increasing corresponds to being above the x-axis. And this, whoops, different color. This decreasing corresponds to being below the x-axis. Did that answer your question? And maybe I should pick different colors when I'm trying to go on the screen. I thought I was doing a good job picking two different colors, but I'm looking at the monitor, I'm going, that blue and green just look like the same thing. Maybe if I change the decreasing to be pink, does that show up any different? No. But, and, okay. Look at the flat spots. This has a 0 after 1. This is implying that the 0 is after 1. The flat spot is after 1, but the flat spot is before 1. Okay. All right. So now, let's try this one. Choice 3, draw the derivative of this. And how you draw it, this one's a simpler one. Figure out where your flat spot is. Okay, so when I look at this, I look for a flat spot. There's a flat spot. That flat spot means the graph is going to cross. Actually, I have grid, kind of, all the grid messes up. That's going to cross at 1. And when I look at this, this is decreasing, which means my graph is below the x-axis. This is increasing, which means my graph is above the x-axis. Oh, so I need something that starts below, hits at 1, and goes above. And if I can scroll through, it looks like E is a good job. All right, our fourth example, our fourth problem. So what does it look like if you've got if you have straight lines? Well, when you have straight lines, it's actually quite a bit easier because, remember, your derivative is slope. So when I look at this, and that picture just messes me up. If I were to make a chart, at -5, the slope of this line is -1. At -4, the slope's -1. -3, the slope's -1. Everything on the left-hand side has slope -1. Since everything on the left-hand side has slope -1, the graph of the derivative of the left-hand side is just this horizontal line at -1. Okay? And if I look at the right-hand side, I want to think, what's the slope? What's the slope of my line on everything on the right-hand side? Well, the slope of the line on everything on the right-hand side is a +1. So whenever you see straight lines, the graph of those, anytime you see just something that's linear, turns out the graph of the derivative is going to be a horizontal line of whatever the slope is. Had this been a slope of 2 on this side, then this would just be sitting up higher. So it looks kind of weird. I remember the first time I saw this, it looked weird that this was different. All right, so